Hey, Brian here from quantlabs.net. Just wanted to go over a very important process that I use to understand algorithms, any script, any programming function, or whatnot. I'm going to show you how to debug code, basically, in a very general level. And most of all, what I want to show you is how to do it with an algorithm and this little application I downloaded yesterday for technical analysis. So let's just talk about debugging and Matlab versus other programming environments. First of all, Matlab's programming environment's probably one of the best ones that I've seen of any language. It's quite good, very advanced, makes you very productive. Regarding other programming environments, there's Visual Studio, Eclipse, and NetBeans. Those are what we call integrated development environments. And Matlab has its own integrated development as well, and that's called an IDE. Now, depending upon the edition of Visual Studio you get, you can get the Express, which is typically free. All the other ones like Eclipse and NetBeans, which are primarily used for Java development. And there's some other ones as well. So let's say you want to develop in R or Python. R has its own development environment or IDE called RStudio. It's quite good. That's how I got into R, because of that IDE. As it stands right now, and I could be incorrect with maybe a new version just came out, I don't know, but up until a certain point, there was no real productive way to debug with what I'm about to show you through a graphical user interface. That is so, in my opinion, very critical to help you make more productive, learn how a piece of code works, and just get you up to speed a lot faster. Now, RStudio doesn't have that, so obviously R, that's probably one of the big drawbacks of R at this point. As for Python, I really never work with Python, so I can't comment a lot about Python, but when I've looked for a standard IDE that's used within Python, there doesn't seem to be one, and I don't know if there's a proper debugging environment like like a Matlab or a Visual Studio or any of those provide. Maybe NetBeans supports Python, and if it does, then you're off to the races, because NetBeans is a great IDE and it supports a lot of programming languages. So do keep those in mind when you're working with maybe open source languages, because this will make your life a lot more productive, and you'll just be able to learn stuff a lot quicker and be able to break down pieces of code when you're looking at them. So what we're going to do in this case, in this demo, is I have an application called Technical Analysis Tool. In there is just a general GUI. It has charting, you can import data, and I've already showcased this application in another YouTube video. It also has analysis functions. In this case, I'm really interested in this RSI for something I'm going to do for simulating. So what I'm going to do is I have my editor. Everything's ready to go. Here's the TA tool, which will call everything and call those analytical functions, in this case RSI. So what I do is set up as obviously as a function, input of data in the period, and has an argument for out, which is the response, which is the return, and that's the output. So in my case, I've set up a breakpoint here, and we're going to run it. So I'm going to cheat a bit. I've imported my data using this import ticker from Yahoo. I'm just using IBM. And I'm going to go into indicator and create a new RSI indicator. Once I go OK, I've set my period at 10. I go OK. And now we've got our execution sitting at the breakpoint. So what we do now is we can continue step in, or step out. Step is the standard pretty well. This is all seems to have changed in previous versions of Matlab. I'm using the latest version. Step in enables you to go and step into a function. So let's say in a case of error, numel, diff, if I come to this breakpoint, I just go step in, and then that will take me into this diff function. So I can do further debugging in a deeper level and deeper in subsequent functions. Now, step out enables you to skip over that function, and then we also have run to cursor, which is wherever my cursor's at, it'll run to that point. So in my case, I'm just going to do a step, and you can just hover over your matrix, your variable, and you can see what the values are. Or there's an easier way. Is in your workspace, you can just double click here and see your entire set of data. And obviously that data is coming in from this chart. Okay, all these data points are populated into this data matrix, and it's the size of 82 by 1. Alright, so hopefully maybe you get a crash course in programming, I don't know. But this is really powerful when you get a really good debugging environment. So it's maybe programming is not as scary as some people may think. Now this little green arrow, as I said, is where the current execution is happening in this line. So as I said, I've got my data. So now what I'm going to do is I'm going to step over the size. And basically what size does, it enables me, here's a description for it. It's right here, this function. So it enables me to see the size of that object, I guess. And what's going to return in this case is the dimensions of m by n. Columns by rows. Alright? And then we got that, so we know it's 82 by n, and we saw that earlier in the workspace. Now it's going to do some checks, and these are all going to fail. So I'm not going to go through that. Those are hopefully pretty simple things to understand. So now I've shown this diff function. You can look it up. But once again, here's the data. Okay, we know it's 82 by 1, as it says there. And we're going to differentiate it. And we're going to step. And here's the DD. Okay. And then we're going to transfer the values of DD, which is here, that's differentiated, into the UC. So that's the upper, I believe. Now, this is the kind of cool thing of a language like R or Matlab. So basically what's happening here is if you see UC, okay, it's going to look for any values less than 0. Obviously they exist, as you can see, negative 1.08, and the next one negative 1.28. So essentially, because those are less than 0, it's going to initialize those as zeros all in one line. So when we do that step, we'll see that, as I said, those lines or those elements in that matrix are now 0. So we're going to do the same thing as before, but we're going to call it DC, right? But we're going to do the opposite, and we're going to call any DC that's greater than 0, as you can see here, and we're going to initialize those as 0. Okay? So if I look now, anything that was over 0, we've initialized as 0. All those elements have been zeroed out. So now all we're going to do is we're going to take the negative ones. You see negative 1.08, negative 1.28, and we're going to make them positive with this negative sign. And you can do these sort of things in Matlab. This is the power of Matlab, and it's meant for this as language. To do this in something like Java or C or C++, you have to, create a for loop and check individual on each one. It'd be kind of hairy. I mean, it could be done, but the convenience of just doing it in one line is great. Okay, so we're going to step over it. So as you can see now, that what was negative is now positive. So it's like running at absolute. Okay, so now, remember I told you about the step in and step out? Okay, so now we're going to do a step in into this Wilder smoothing function. It's right here. So we're going to step in, and now we're in the Wilder smoothing function. So again, we have our data period as the arguments. Here's the values of data and period. Okay. Now I'm not going to go into great details with all these algorithms and stuff. I mean, honestly, I'm still trying to figure those out, and that's something that could take a while for me to figure out. But all we care about is just showing you the debugging process, right? Walk you through it generally. So we're going to do another size. We're going to return the M&M as we did before. Do those various checks. Now we're going to find out the length of data, which is going to be 81. Okay, so we're going to step. Right? So our LD is 81. So is the LD less than the period? No, it's not. So it's going to do all these sanity checks. So I'm going to step. Is LD equal to 10? No. Now it's going to just do the else. Now this is this is the weird stuff, the calculations, but I'm not going to get into that. But I'll try my best to explain it. So we're going to set our out, which is our out right here. I'm going to have not a number, NaN, times 1, and it's going to 1 all the data values. So let's see what happens here. So we're going to step. So now if we look at the out, they all become NaN. So if I go look just to verify that in the workspace, out, there you go. NaN are all NaN, not a number. Okay. So now we're going to do this weird calculation. I'm not going to explain it. It's going to do some filtering. I'll let you investigate that. That could take me quite a while to explain it. But we're just going to step over it. And now we have a new out. Okay. So if I look at the workspace again, so now we have some form of filtering calculation that's been applied, and we can return back to where we were before. So I'm going to do a step. So that should, I think I do one more. Yeah, so that takes me back to RSI. So now we've run the first Wilder smoothing, so I'm just going to do a step to skip over it. I mean, I think a step out would do the same. I'll just do a step. So now we have this WUC, and WDC from the Wilder smoothing. Okay, so let's check out those values in the workspace. So these are what was calculated from that filtering process in the Wilder smoothing. Okay. So now what we're going to do is go back in the editor. Now we're going to do our actual RSI calculation. Now let me just show you what RSI is. Investopedia, I find Investopedia RSI for definitions is quite easy to pick up. Alright, so don't you just love these commercials? Continue the site, thank you. So I'm not going to get into the details of RSI, but I know that there was a calculation. This is the calculation right here, and this is what we're going to do. Okay, so 100 minus 100, 1 plus WC, and I think there's one more. Okay, so let's just do that. Step. So now we've got a new set of data, which is really our RSI. So if we go back to out, these are now calculations for our RSI. Okay, all is 27, 51. Now essentially, that calculation I just showed you, so in this case, what we're looking for is if the asset approaches 70, means that it's overvalued and it's a pullback. So I'm going to create a Simulink model around this. So I could have a really primitive, very simple Simulink model saying, oh, if it's over 70, maybe it's time to sell, right? So it's a signal, right? So now we have our 30, which is the reverse. If the RSI approaches 30, indicate the asset may be getting oversold and undervalued. Buy it. So again, another signal. So I'm going to create a whole simulate model around this with a stateful chart. That's my next step. But I wanted to understand how this function works, and so I debugged it just to understand it, and I have a better idea of it outside it. I mean, this one I get. It's this Wilder smoothing. This line's kind of crazy, so I have to understand that better. But let me just finish up this execution. So I'm right here at the end, and I go step, and I can actually continue, right? And we're essentially done. Like, we've gone through that process. So if I come under the command, we are kind of finished. So I can just close this out. And yeah, I think that's it. So hopefully it'll give you a better idea of how I debug within Matlab, give you a better idea, you know, a really powerful debugging environment like this. Hopefully you take away a lot of info from it, and especially if you're new to programming and maybe from a trader going into programming. Talk to you later.